Hello, excuse me. Good morning, everyone. We are the group 2. Our reporting for today is preparation and standardization of Aoh Solution. Next, please. Objectives. First is to understand acid-base titration. Second is to perform and analyze the reactions before the given chemicals. And lastly is to know the normality and molarity of the solution used in the experiment. Next, please. The materials that to be used is first is NaOH pellets. Second is potassium acid. And last is phenolphthalein. Thank you. Next, please.
For the preparation of an AOH solution, first weigh roughly 20 grams of NaOH in a previously tiered small beaker. Then add distilled water to dissolve the NaOH and pour the NaOH solution into a 1 liter volumetric flask. Rinse the beaker with the distilled water and pour the rinsing into 1 liter volumetric flask. Then, add enough distilled water to complete the volume to 1 liter and store the solution in a 1 liter stock bottle with plastic cap and label properly.
For the standardization of NaOH solution, first is weigh accurately 1.5 to 2.0 grams of KHP into an Erlenmeyer flask. Next is dissolve with 50 ml of distilled water by shaking the flask. Next, add 2 drops of phenolphthalein indicator. Next is to titrate to a faint pink color using a base burette. Next is to perform 2 determinations, and lastly, determine the normality of NaOH solution.
So on the screen, here are our formulas to be used in this solution. So we will discuss this further more later.
Wait lang. Who's speaking? Hindi ko marinig masyado.
Ako po, ma'am. Kalim po, ma'am. Audible na po, ma'am.
Okay, so here's the result of our data. For the weight of our trial 1, it is 1.81 grams, and the volume of NaOH used in the trial 1 is 35 ml. And the normality of NaOH is 0.2535 N. And its molarity is 0.2535 M. For the trial 2, the weight of KHP is 1.82 grams. The volume of NaOH used is 26.2 ml. The normality of NaOH is 0.3405 N. And for its molarity, 0.3405 M.
Hello po, ma'am. Am I audible po?
Yes, Shan. Sige.
Okay po. Ako po pala yung nagsasalita kanina, ma'am. For our molar mass of C8H5KO4, so we have the 204 grams per mole. So in order to get the MEQ, the weight of MEQ, we need to divide the MM over F times 1000. Therefore, 204 grams per mole divided by 1 times 1000 MEQ per mole. So we have gathered a 0.204 grams per MEQ. For our trial one, we have the weight of 1.81 grams, a ml of 35 ml, the weight of our MEQ, the 0.204 grams per MEQ. So for our normality, weight over ml times MEQ weight is equal to 1.81 grams over 35 ml times 0.204 grams per mole. Therefore, we have the 0.2535014 MEQ per ml, or our normality as 0.2535 N. For our trial 2, our weight is 1.82 grams, and we have the ml of 26.2 ml. MEQ, weight of MEQ, 0.204 grams over per MEQ. Therefore, we have the normality of weight equals over ml times MEQ WT equals to 1.82 grams over 26.2 ml times 0.204 grams per mole. And we have the normality of 0.3405 N.
So for the explain the use of phenolphthalein in the procedure. Phenolphthalein is a colorless, weak acid that is widely used as an indicator in titration experiments to indicate the endpoint of the titration. The endpoint is indicated by the formation of a pink color since this compound dissociates to form pink onions when dissolved in water. Distinguish between equivalence point and the endpoint. Equivalence point represents the stage of titration where the concentrations of titrate and titrant are chemically equivalent. An endpoint represents the stage of titration that indicates the completion of the titration with the help of the change in color or intensity of the solution.
Distinguish between direct titration and back titration. The main difference between back titration and direct titration is that a back titration determines the concentration of unknown by determining the remaining amount of the compound with a known concentration, whereas a direct titration directly measures the concentration of unknown compound. Distinguish between primary standard and secondary standard. Primary standard are reagents that can involve in chemical reactions. These compounds are often used to determine the unknown concentration of a solution that can undergo a chemical reaction with the primary standard. A secondary standard solution is a solution that is made specifically for a certain analysis. It is not that pure and is chemically reactive that primary standard.
For our conclusion, wait lang. to summarize, the primary objective of a strong base titration is to determine the concentration of an acid solution by titrating it with a known concentration of a basic solution, or vice versa, until neutralization occurs. As a result, the interaction between strong acid base and strong base will produce salt and water. Titration is important to chemistry as it enables for the precise measurement of analyte solution concentration.
Okay. Are you done? Ayun na. Let me request remote control. Siya. Okay, sige. Pabalik na lang sa ano. Nag-skip ata tayo ng experiment, no? Meron pang sa gitna nito, diba? Experiment 9. I think this is experiment. Hindi ko na masundan ang numbers ng experiment. This is 11. So, merong experiment 10 pa pala. Let us check. Okay. So again, this is acid-base titration, preparation and standardization of sodium hydroxide solution. Yeah, don't 10 kay freezing point. Sino mag-report nun? Ano sabi ko? Kasunod ata dapat? Wala. Bakit wala? Bakit wala mag-report? 4 groups kayo, diba? Tama ba? Group 1 will be reporting activity number 9. That is the boiling point. Sabi ako 9, 11, and 12. Nakalimutan ko. Can you remind me? Ano sabi ko doon? Tabang, mga langit. So who will be, what will be the group 4's report? Anong report ng group 4? Boiling point? Dahil lang, 9 ang 9 kay ang group 1.
Kami po, ma'am.
So, ang experiment 10 should be group 2's report. Tama ba? Pasunod, di ba dapat tayo? Tapos sabi ko, group 3 should be reporting this. Experiment number 11. And then the group 4 will be doing experiment number 12. So what will be the report of group 4 now? Anong prepare ng group 4? Bakit parehas ang report ng group 3 and group 4? Hindi ko ata. Nagsabi ba ako na parehas kayo ng report? Ba't di ko paalala? Asan ako sa Earth? Nabiling. Ano sabi ko sa experiment number 10? Hindi ko kasi hindi kasi tayo nagdo-double report. Kasi kung magre-report na ang group 3 ng experiment number 12, bakit magre-report din yung group 4 ng experiment number 12? Hindi ko siya makita. Yeah, kailangan isingit kasi yun in between.
Nakalimutan lang ata, ma'am, kay ang latest natin na experiment kay yung 9, 11, and 12.
Yeah, ang 9, 11, and 12, ayun yung ating yung face-to-face class. But do not forget, we still have one, and that is activity number 10, and that is included in the finals. Kaya nalito ako, bakit nag-skip? Well, though since nag-start naman na, hindi ko na lang siya stinap. So ipaulahin na lang ang experiment number 9. Yeah, 9. This is activity. Experiment 10 pala. So sino yung magre-report ng experiment number 10 ngayon? Kasi pasunod man na. Ang malala dyan ako ng instruction pasunod from the first experiment group 1. Ang sunod niya experiment succeeding na yun. Kasi yun naman talaga ang trend natin ever since. Parang nakalibog kung anong nag-skip. So, since ni-report naman na ng group 2 yung experiment number 11, Group 4 will be reporting activity number 10. Kasi I think yung group 3 nag-prepare ng experiment number 12. So talagang mapupunta sa group 4 itong activity number 10. But anyway, I believe hindi niyo yan na-prepare. Let's have that on Monday. I hope may klase pa sa Monday kasi bigla-bigla lang yung mga klase sa world. Pero I do hope so kasi wala kayong grade sa akin kung hindi kayo makapag-report. Kung wala naman, i-video nyo na lang siya para may grade pa rin kayo sa akin, and then let's just upload your video. Okay? Pag wala, pero pag meron, please prepare for activity number 10. Kasi 4 yung activity. 4 activities tayo per semester. Nauna lang talaga yung activity number 10, pero finals pa rin naman natin yun ginawa. So kasali pa rin yun. Okay? So anyway, let's move on. We have sodium hydroxide solution here. Trabaho talaga yan, class, ng analytical chemist. Chemist in the laboratory to prepare solutions with different concentrations. Kasi there are a lot of procedures that require, example, itong procedure na ito, nagre-require ng 1 normal sodium hydroxide. Meron ding other procedures that will require you like 2 normal na sodium hydroxide. So magkaiba-iba yun siya. And it's very important for us to know how to prepare them and how to determine the accurate concentration of this prepared solution. So in this experiment, you were asked to prepare sodium hydroxide solution using 20 grams of the sodium hydroxide pellet, which I told you a while ago that this one is a hygroscopic substance, meaning it has the ability to absorb moisture from the environment. And since it can absorb moisture, nag-iiba yung concentration nun. Kaya before using sodium hydroxide solution, it has to be standardized first. So again, when you say standardization, we are measuring, we are identifying or determining the concentration of the solution. So after nyo ginawa yon, yung sodium hydroxide solution yon, nag-standardize tayo using a primary standard. Okay, I hope you will not forget that. Again, ang ginawa nyo for the standardization of sodium hydroxide solution is you used a primary standard, and that is the potassium hydrogen phthalate. That is, again, the primary standard. So, nag-weigh kayo nito, and pag nagamit ka kasi ng primary standard, supposedly, di ba, our sample is the sodium hydroxide, but in the case of using primary standard, the primary standard will act as like an analyte. It will be the one to be placed in the Erlenmeyer flask and added with phenolphthalein. And then, the supposedly sample will be used as like a titrant kasi it will be the one to be placed in a burette and added sa Erlenmeyer flask until you reach the endpoint. Okay? Again, primary standard ito. Now, in titration class, we always assume na mag-annotate ako ha. Saan yung, type na lang ko. We assume, class, that the normality of the analyte or even the molarity, let's just add molarity here, will be equal to the normality or the molarity, and that is referring to the concentration of the titrant. That's the meaning of equivalence point. So in the computation, even if we use the potassium hydrogen phthalate, we can still assume that it is also the normality of the sodium hydroxide. Kasi again, sa titration, we assume that the concentration or actually the milli-equivalent weight of the analyte will be equal to the titrant. So look at the formula in the screen. The normality of the sodium hydroxide is still equal to the grams of the primary standard, which is the potassium hydrogen phthalate, divided by its milli-equivalent weight, that is still for the potassium hydrogen phthalate. Kung kaninong weight yung ginamit, ganun din yung milli-equivalent weight ha. So KHP, KHP yan siya. And then for the ml, that should be for the titrant. So in this case, our titrant is the sodium hydroxide. Okay? Pero yan yung sample natin, but at the end of the day, their concentration will be equal. Okay? So these are your results. 1.81, 1.82. Oh, there is a discrepancy with the volume of the sodium hydroxide used. There are factors also why we have different results for different trials. That is why meron, hindi ko alam kung dito sa worksheet na yun yung kukunan mo ng average, pero I think nasa activity 12 yun. Kukunan natin siya ng average. Okay? Merong discrepancy yan talaga. Maybe due to environmental factors. Remember, sodium hydroxide is a hygroscopic substance. So maybe after second trial, it has already absorbed some moisture coming from the environment. Or maybe because of the weight of the potassium hydroxide, marami tayong reasons. Normality of the sodium hydroxide, I have computed this a while ago. I guess meron kayong ayan. This is the molar mass of the potassium hydrogen thalate. That's 204 grams per mole. Computing for the milli-equivalent weight, this is correct. The equivalence factor for the potassium acid thalate is 1. Even though it has 5 hydrogen, only 1 hydrogen is replaceable. So that is 1, 204. So for trial number 1, that's 1.81. Divided by 35. Okay, sige. Tama yan siya. And then, hindi ko maalala kung tinuro ko yung shortcut, no? Pero I think so. Yung shortcut natin, normality to molarity. You just have to multiply normality sa kanyang equivalence factor and you will get the molarity. Okay? Just cancel the unit. Pag hindi ma-cancel, baliktarin mo ang unit. Ganito. Like 0.2535, you use equivalent per liter times the F, 1, diba, for sodium hydroxide. So that is supposedly 1 equivalent per mole. So kung hindi siya hindi kasi siya maka-cancel kapag ganito. So, in this case, baliktarin mo siya. Lagay mo yung 1 sa baba, and then dito ang mole sa taas. Okay? And then, cancel the equivalent. So, it's the time you get 0.2535. Nasa taas na si mole, sa baba si liter. And then remember, moles per liter is equivalent to capital letter M. Okay? So, that is correct. The same, basta 1 ang factor, the same talaga yan ang normality and molarity. Magbabago yan siya pag magbago din ang factor niya. Like sa mga cases ng compound na 2 or 3 ang factor, equivalence factor. This is also true, it's just that meron tayong difference sa ml ng NaOH na nagamit. Kaya hindi pareho yung normality and molarity ng both trials. That's okay. Phenolphthalein is, again, an indicator. So it's an acid-base indicator that will change color depending on the environment where it is added. Okay? Colorless yan siya pag acid environment and pink pag basic environment. Equivalence point and endpoint, pinaulit-ulit ko na ito. Equivalence point is the theoretical point wherein we assume that there is an equal amount of sodium and titrant that has reacted with each other. Yung endpoint, yung actual sa experiment na makikita natin that there is a change in color. We cannot see kasi, we cannot observe with our naked eye the equivalence point, only the endpoint. Direct titration, directly titrate natin 1 analyte, 1 titrant. While for the back titration, it is also called indirect titration. We have 1 analyte and 2 titrants. 1 titrant is added in excess, and then the second titrant will be used to titrate the excessive titrant na naunang i-add. Primary standard and secondary standard. Primary standard is solid, very pure material used during titration. While the secondary standard is a solution, so it is a liquid. Okay? When it comes to purity, yung strict tayo, primary standard talaga. Kailangan muna 99.9% pure siya. Kaya medyo konti lang yung primary standard natin. Okay? Questions about activity number 11? Yeah, 11. Wala.